In this video, we will see few questions, previous year university questions from Module 2 of Fluid Mechanics and Hydraulics. So let's move to the first question. I have taken the question from September 2020. The questions are, how is the metacentric height of a body determined experimentally? And second question is of 10 mark. A solid cylinder of diameter 5 meter has a height of 5 meter. Find the metacentric height of the cylinder if the specific gravity of the material of cylinder is 0.7 and it is floating in water with its axis vertical. State whether the equilibrium is stable or unstable. So let us find out the first question, that is how to find out metacentric height of a body experimentally. So this is how we experiment a determination of metacentric height. First, we will take a bigger body, this orange one, this one, and we will place a small weight W1 above it. Okay, so W1 is the weight of the small body and capital W is the weight of the entire body, the body including small body. Okay, so capital W is the weight of total two bodies, and small W1 is the weight of small body. Now we are going to tilt this setup. So when I tilt the setup, the center of gravity will change from G to G1 and center of buoyancy will change from B to B1. And if I draw a straight line, it will make an angle theta. And this W1 will definitely move from this point to some other point. Let's say the W1 has moved a distance of X. And this triangle MGG1 will be right angle triangle. So this is how the body will be when we give a smaller tilt. Okay. So for equilibrium, moment due to the moment of W1 will be equal to the total moment due to weight of the body. So in order to keep this entire two bodies in equilibrium, we can say if they are staying in equilibrium, the moment developed due to the movement of the small W1 should be equal and opposite to the moment developed due to the entire body. So we can write the moment developed due to the small bodies W1 into X in clockwise direction. W1 into X will be acting clockwise, and in order to keep this entire setup equilibrium, the total weight should act anti-clockwise upward. So total weight will be acting W1 into this much distance G into G1. This is the place where weight will be acting, center of gravity. Okay, so W into G1 should be equal to W1 into X. From this we can write G1 is equal to W1 into X by capital W. Now from triangle MGG1 we can write tan theta. This is a right angle triangle. So tan theta is opposite side by adjacent side. Opposite side is GG1, adjacent side is MG. So I can write GG1 is equal to MG into tan theta. So we have got two equations for GG1, W1x by W and MG into tan theta. Now I am going to write down or equate both the equation, or I can also write, instead of GG1 I can write W1x by W. Both are same. So MG tan theta is equal to GG1. So MG is equal to GG1 by tan theta, where GG1 is replaced with this equation W1x by W tan theta. This MG is known as metacentric height, distance between metacenter and center of gravity. So Mg is W1 into X by capital W into tan theta. So this is how we calculate metacentric height experimentally. Now moving to the second question. A solid cylinder of diameter 5 meter and height of 5 meter. So we have a solid cylinder with diameter 5 meter 5 meter. Height is also 5 meter. Find the metacentric height of the body if the specific gravity of the material is 0.7 and it is floating in water with its axis vertical. So it's floating in with its axis vertical. We have to find out whether it is in equilibrium or not. So first you must know the equation of metacentric height. Metacentric height can be calculated by using equation I by V minus Bg, where I is the moment of inertia, V is the volume of immersed portion of body. So here let's say only this much portion is immersed. So we have to find out the volume of the immersed portion alone. Okay. So V is the volume of immersed portion of the body. Bg is the distance between center of gravity and center of buoyancy. So depth of immersion can be calculated by using the equation. Depth of immersion is equal to specific gravity of the body into height of the body. This is very, very important. Depth of immersion is equal to specific gravity of the body into height of the body. So when you place any object in water or in any liquid, this depth of immersion should be equal to specific gravity of the body into height of the body. Say height of the body is h, specific gravity is g, then depth of immersion is h into g. Okay. So let us find out depth of immersion. H is equal to 0.7 g. Here depth of immersion is taken as small h. So h is equal to specific gravity is 0.7, height is 5. So depth of immersion is 3.5. Now center of buoyancy. Center of buoyancy will act at the middle of the depth of immersion. So we have to find out the middle point, that is 3.5 by 2, which is 1.75 meters. The volume of the immersed portion of the body will be equal to W. We know how to find out the volume of a cylindrical body. If it is having a diameter d and h as a height, then volume is pi by 4 d square into h. Here we have to find out only the volume of immersed portion, and we have taken the depth of immersion as small h. So here the small h is the depth of immersion. So this is our depth of immersion and d is the diameter. So pi by 4 d square into h is the volume of the immersed portion of the body. So we just substitute, where diameter d is pi meter itself and small h is 3.5. Substitute, you will get the answer as 68.72 meter cube. Now center of gravity. Center of gravity will be acting at the middle of the cylindrical body. So total height is 5. So middle will be 2.5 meters. Now we have to find out Bg, distance between center of buoyancy and center of gravity. That we will do just by subtracting these two values, 2.5 minus 1.75. So you will get Bg, distance between center of gravity and center of buoyancy is 1.75. So look at here, we have the cylinder and which is immersed in water at a depth of h, which is h. Here we have got 1.75, sorry, 3.5. So the center of buoyancy will act here, which is at a height of 1.75, and center of gravity is acting at a height of 2.5, which is at the middle of the cylinder. So we have to find out the distance between B and G, that is 2.5 minus 1.75 will give you the Bg. Okay, that is 0.75. Now we will apply all those values into the equation mg is equal to I by V minus Bg, where I is pi by 64 d square for cylinder. So we just substitute the value and you will get it as a negative value. Negative value indicates that meta center is below center of gravity, which is unstable. If the value is positive, it indicates metacentric height is above center of gravity, which is stable. So here what we have got is minus 0.773, which is negative value, that is metacentric height, or sorry, metacenter is below center of gravity, which is unstable. Okay. Now moving to the second question paper, that's also from same question paper. The question is, the velocity vector in a fluid flow is given v is equal to 4x cube I minus 10x square yj plus 2t k. Find the velocity and acceleration of the fluid particle at 2, 1, 3 at time t is equal to 1. So here it is given the coordinates x is equal to 2, y is equal to 1, z is equal to 3 and time is 1. So in order to find out the velocity, velocity can be written in terms of ui plus vj plus wk. From the equation v is equal to 4x cube I minus 10x square yj plus 2tk, we can extract u, v and w. So here u is 4x cube, v is minus 10x square yj, minus 10x square y and w is 2t. So we have the value of x, y, z and t. So just substituting the values, you will get u as 4 into 2 cube, which is 32. V is equal to minus 10 into 2 square y, which is minus 40. W is 2 into t, which is 2 itself. So in order to find out the velocity, you must write, you have to find out v is equal to root of u square plus v square plus w square, where u is 32, v is minus 40 and w is 2. Just square it, add it and find the square root, which will give you the value of velocity, that is 51.26. Now moving to the acceleration part. Acceleration have to be calculated by using differentiating the velocity term. So ax will give you differentiating the dx term of velocity, which is u. So d by dt of u will give you the acceleration in the direction of x. D by dt of v will give you the acceleration in the direction of y coordinate, and d by dt of w will give you the acceleration in the z coordinate. So we will find out the differentiate d by dt of u by partial differentiating each terms, dou by dou x of u into u plus dou by dou y of u into v plus dou by dou z of u into w plus dou u by dou t. Similarly, we will find out dou by dou t of v as dou by dou x of v into u, dou v by dou y v, dou v by dou z w plus dou v by dou t. And az is dou by dou x of w into u, v into dou w by dou v, w into dou w by dou z plus dou by dou t of w. So first we will find out dou by dou x of each u, v, w, dou by dou y of u, v, w, dou by dou z of u, v and w. So first we will write down what is u, what is v and what is w. And we have the value x, y, z and t. So dou by dou x of u. Look at here, 4x cube. When you differentiate, it will become 12x square. Now substituting the value of x is equal to 2. So 12 into 2 square, which is 48. And there is no v, y, z and t term in u. So dou by dou y, dou by dou z and dou by dou t of u is 0. Now dou by dou x of u is minus 10 into 2 into x into y, which is when substitute x is equal to 2, y is equal to 1, you will get minus 40. Dou by dou y, with respect to y, when you differentiate, it will become minus 10x square itself. And when I substitute x, you will get again minus 40. And dou v by dou z, there is no z and t term, so both terms are 0. And for dou w by dou z, dou x, y terms are not there in w. So x, y, z terms are 0. Only t is there. So dou by dou t of w is 2. Now we will find out the value of u, v and w that we have already found out for velocity. Now substitute these values here. So here we have u into dou by dou x, which is 48 into u value is 32. All other values are 0 because these terms are 0. So 0 plus 0 plus 0. And dou, so when you calculate, you will get 1536. And dou v by dou t. So dou v by dou x is minus 40 into u is 32 plus this one is again minus 40 into v is minus 40 itself. So when you find out, value is 320. All other terms are 0. Right? And for this one, ax, az, this one is 0 plus 0 plus 0 plus 2. So the value is 2. In order to find out the acceleration, you have to find out ax square, ay square, az square and add up and find the square root. So a is equal to root of ax square plus ay square plus az square. And you will get the answer of acceleration as 1568.9. Next question is, describe the velocity potential function and stream function. So we can define the components of resultant velocity v as a function of space and time. We just have seen that we can write u, v, w in terms of x, y, z and t. So total resultant velocity is root of u square plus v square plus w square. Now velocity potential. It is a function basically defined as scalar function of space and time such that its negative derivative with respect to any direction will provide us the velocity of fluid particle in that direction. So velocity potential function will be represented by the simple phi, and velocity potential dou phi by dou r or dou phi by dou theta into 1 by r will give the radial and tangential direction of velocity components. So we can write the continuity equation for incompressible steady flow in terms of velocity potential as dou by dou x of minus dou phi by dou x plus dou by dou y of minus dou phi by dou y plus dou by dou z of minus dou phi by dou z is equal to 0. Or we can square it, not square it, when you dou by dou x of dou phi by dou x is dou square phi by dou x square, dou square phi by dou y square and dou square phi by dou z square, which is equal to 0, and this is the Laplace equation. Now moving to stream function. Stream function is defined as scalar function of space and time such that its partial derivative with respect to any direction will provide us the velocity component perpendicular to the direction. So the velocity component perpendicular to the direction will be given by stream function, and it is indicated by phi, and it's only defined for two-dimensional flow. So dou phi by dou x is v and dou phi by dou y is minus u. Okay. And for polar coordinates, we can write stream function as dou phi by dou r, where u r is radial indicating the velocity component direction, u theta indicates the velocity component in tangential direction. So you must know that dou psi by dou r is equal to minus u theta, and dou psi by dou theta in 1 by r is ur. Okay. So the value of u and v in continuity equation is dou by dou x into minus dou psi by dou y plus dou by dou phi into dou psi by dou x is equal to 0, which is minus dou square phi by dou x dou y, and dou square psi by dou y dou x is equal to 0, which is indicating a possible case of a fluid flow. So we can say the existence of stream function indicates a possible case of fluid flow, and flow might be rotational or irrotational. If the stream function satisfies the Laplace equation, it will be a possible case of an irrotational flow. Now moving to the second question paper, that's from December 2019. The first question, a solid cylinder with diameter 3 meter and height 2 meter. Find the metacentric height when it's floating in water with its axis vertical. The specific gravity is given as 0.6 and we have to state whether the body is stable or not. So we have done the same kind of question before. The equation for calculating metacentric height is I by V minus Bg. And depth of immersion can be calculated by multiplying specific gravity of the body and height of the body. So here specific gravity is 0.6 and height is 2. So depth of immersion is 1.2. Now center of buoyancy will act at the center of the depth of immersion. That is at a height of 0.6 meters from the base. So volume of the immersed portion of the body is pi by 4 into d square into h, where d is 3 meter and h is 1.2. So the center of gravity is acting at the middle of the total height. So total height is 2 meters. So at the middle means 1 meter from the base. So the distance between center of gravity and center of buoyancy, that is Bg, is 0.6 and difference of 0.6 and 1, which is 0.4 meters. Now we substitute into the equation mg is equal to I by V minus Bg, where I is pi by 64 d square. When you substitute the value, you will get it is minus 0.37. Since the value is minus, it indicates metacenter is below the center of gravity, which is unstable. Now, the second question was to define the terms streamline, path line, and streak line. So, streamline is basically an imaginary curve drawn through a flowing fluid in such a way that the tangent to it at any point gives direction of velocity of flow at that point. So this is a figure of streamline. You can see here the tangent is showing the direction of the velocity at that point. Now path line, it is a trace of a single particle of a flowing fluid, or we can say it's a trajectory of a fluid particle, or we can also say it's an actual path traveled by an individual fluid particle over some period of time. Let's say we are pointing out a single particle over here and we will draw a track along its trajectory, then we will get a path line. So path line shows the direction of velocity of an individual particle at any instant of time. On the other hand, streamline shows the direction of velocity of number of fluid particles at that instant. Now coming to streak line, in order to find out the motion of the fluid particle in experimental work, we use color or a dye or a smoke in case of gases, which will be injected into the fluid in order to trace the motion of fluid particles. And the resulting trace of the color is called streak line. A streak line can be defined as the line that is traced by the fluid particle passing through a fixed point in a flow field. The streak line is the locus of the temporary location of all particles that have passed through a fixed point in a flow field at any instant of